So today we will do the theorem. One of the property that we can say about the measurable set, that every interval is a measurable set. Every interval is a measurable set. So any interval means here, interval may be finite, may be infinite. It may be of the form this, it may be of the form this. So we will discuss all kind of cases. It may be of this form, it may be of this form, minus infinity to a, may be open, or here may be closed. So all cases we will discuss one by one. So let I be an interval. Let I be any interval. Right? So case number one. When I is equal to the interval a to infinity. I is an interval, then we have the following cases. So what we want to prove? We want to prove I is measurable. What does it mean? That is for any set A, m star A is equal to m star A intersection I plus m star A intersection I complement, right? So we will put the values. This is what we want to prove. Okay, for any set A, we claim that. We can write over here, we claim that is. So now I will put the value of I here. That is m star A. So we can also take as it greater than or equal to. This is a sufficient condition for a set to be measurable set if m star is greater than or equal to m star A intersection E plus m star A intersection E complement. So I will put the value A intersection A to infinity here plus m star A intersection A to infinity its complement, right? That is, this is greater than or equal to m star A intersection, let it be named A1 plus m star A2. So what we want to prove that m star A is greater than or equal to m star A1 plus A2, where A1 is equal to A intersection this, and what is A2? So I will take the complement of this, A intersection minus infinity to A, right? If m star A, step number one, if m star A is equal to infinity, clearly if m star A is infinity, then infinity is greater than or equal to sum of the outer measure of two sets, which is obviously true, which is obviously true. So there is nothing to prove. So now we will take the case when, let us assume that m star A is less than infinity. Right? So now we will use the definition of outer measure. So therefore, by definition of outer measure of a set, m star A, this is equal to what? This is the infimum of summation of length of In, where In is a countable family of open intervals such that A is contained in union of I, right? Therefore, for a given epsilon, by definition of infimum, for a given epsilon greater than 0, m star A plus epsilon is not the lower bound of the set. कौन सा set? Summation and running from 1 to infinity length of In, where A is contained in union of In of this set. अब आप नंबर लाइन पे देखिए, ये मेरा m star A है क्योंकि ये infimum है. ये ग्रेटेस्ट लोअर बाउंड है, इसके पीछे वाले सारे लोअर बाउंड्स हैं, उनमें से ये m स्टार a जो है दिस इज द ग्रेटेस्ट लोअर बाउंड। इससे अगला नंबर m स्टार a प्लस एप्सिलॉन इज नॉट द लोअर बाउंड। लोअर बाउंड सारे लेफ्ट साइड पे होंगे, राइट साइड पे कोई लोअर बाउंड नहीं होगा, राइट। सो इट इंप्लाइज देयर एग्जिस्ट अ नंबर, किस सेट का, इस सेट का लोअर बाउंड नहीं है, इसका मतलब इस सेट का एक मेंबर यहाँ पे एग्जिस्ट करेगा जो इससे क्या होगा, छोटा होगा। इट इंप्लाइज देयर एग्जिस्ट अ countable collection of open intervals such that A is contained in union of in and summation of length of in is less than or equal to m star a plus epsilon. Let it be number 1, right? So this is just what we have done. We have just use the property of outer measure and then we have used the property of greatest lower bound. Now we will come to the step number 2. Let I, हम दो इंटरवल्स बनाएंगे, i n dash is equal to i n intersection open interval and i n, this is i n intersection minus infinity to a, right? Then clearly in and in dash are open intervals. Now we will find their union, in dash union in double dash. So in union पहले इसकी वैल्यू पुट करेंगे, this one, then you will have union here, then in intersection minus infinity to a. So this becomes in, right? Union in and here will be intersection a infinity union minus infinity to a. So this become in intersection minus infinity to infinity, that will become in. So when you will take in dash intersection in double dash, so here the same value you will get here, minus infinity to in intersection, again you will have union, so यहाँ पे आ जाएगा a to infinity intersection minus infinity to a, so that will be 5, so intersection you will have 5. So therefore these both are intervals. So what we have proved that in dash union in double dash, that will be in and in dash intersection in double dash, this is equal to 5. So length of in dash, it implies length of in dash plus in double dash is equal to length of in. Let it be number 2. Now next is the step number 3. A1 was A intersection A to infinity and A is contained in union of in, right? Intersection A to infinity, right? So union अंदर जाएगा in intersection A to infinity. What is this is union of in dash. Similarly, it implies A1 is contained in union of in dash. Similarly, A2 is contained in union of in double dash. Now we will find the measure of A1 and A2. It implies by the definition m star A1 is less than or equal to m star union of in dash. This is less than or equal to m star in dash and running from 1 to infinity, and outer measure of an interval is its length of in dash. Similarly, m star A2 will be less than or equal to summation of length of in double dash. So we have to add to find the final answer to prove the final result. Summation of length of in dash plus summation of length of in double dash, and this comes out to be summation of length of in, and by number 1 this is less than or equal to m star a plus epsilon. So it implies, let epsilon tending to 0. So what you will get, m star a1 plus m star a2. This is less than epsilon. Oh, sorry, this is less than or equal to m star a. It implies m star a is greater than or equal to m star a1 plus m star a2. Hence, we have proved the first part. Our claim is true. Right? Therefore, the interval a to infinity is measurable. This we want to, I is equal to this is measurable. Right? So, next is case number 2. When I is equal to minus infinity to a. Since complement of a measurable set is measurable, right? It implies a to infinity. ये already क्या था? Measurable. तो इसका complement भी क्या होगा? Is measurable, right? Then case number, it implies minus infinity to a is measurable. So now we have case number 3. When I is of the form minus infinity to b. So how we can write minus infinity to b? It is written as union and running from 1 to infinity minus infinity to b minus 1 by n. So when you will represent on the number line and when you will take n tending to infinity, the set will be converted into minus infinity to. Here is open interval. Here is not a closed interval. इस b की जगह पे हमने कर दिया b माइनस 1 बाय n और साथ में हमने लगा दिया यहाँ पे इसको क्लोज्ड ब्रैकेट दे दी. ठीक है जी. अब स्टेप नंबर 2 से इस तरह का सेट क्या है? मेजरेबल. सो बाय स्टेप नंबर 2, minus infinity to b minus 1 by n is measurable. It implies an countable union of measurable set is measurable. Therefore, union and running from 1 to infinity minus infinity to b minus 1 by n is measurable. ठीक है जी. It implies minus infinity to b is measurable. Now we have case number 4. Case number, when I is equal to the finite interval a to b. So how you will express a to b? This is a to infinity and minus infinity to b. A to infinity. So I is expressible as I is equal to the open interval ab is expressible as minus infinity to b intersection a to infinity, right? So by case number 2 and 3 both are measurable. ठीक है जी. ये भी measurable है, ये भी measurable है. By case number 2 and 3 the intersection, it implies intersection of two measurable set is measurable. It implies the interval a to b is measurable, right? So we have considered all the cases, whether finite or infinite. Therefore, every interval is measurable, right? So let's do some of the corollaries. Corollary number 1. Every open set, suppose karo you have a question in the paper, every open set is measurable. So, every open set is expressible as a union of open intervals, right? Let O be an open set. Let O be an open set. Then, O can be expressed as the union of open intervals. ठीक है जी. That is O is equal to union and running from 1 to infinity in, where in is open interval for all n. And we have proved in the previous theorem every interval is measurable. As every interval is measurable, whether it's open, it's finite or infinite, it is measurable, right? But in is measurable for all n. This is by previous theorem. The major theorem, every interval is measurable. So it implies and countable union of measurable set is, you will write here countable union of measurable set is measurable. It implies union of in is measurable. It implies O is measurable. That's all, right? So we have corollary number 2. Every closed set is measurable. Every closed set is measurable, means measurable. मान लिया, let F be any closed set. Its proof, let F be any closed set, right? It implies F complement is an open set. It implies F complement is measurable set, and the complement of a measurable set is measurable. Complement of ये अपने आप में एक set है, उसका complement हमने लिया is a measurable set. It implies F is a measurable set. Therefore, every closed set is measurable set. So this is all about the theorem that every interval is a measurable set and every open set is measurable, every closed set is measurable.